Good everyone, my name is Graphics. Today we want to solve another problem in stress and strain in bars. We'll be analyzing that question at the top right corner of the screen. And the question goes like this. It says, find the minimum diameter of a steel wire which is used to raise a load of 5,000 Newton if the stress in the wire is not to exceed 95 meganewton per meter square. So in questions like this, the first thing you have to do is to write out your parameters. Now we have the data given. The data. Now it says the minimum diameter. That means we're looking for diameter D, which we don't know, right? And we are told that it is used to raise a load of 5,000 Newton. The load is given as what? As the force. And that is given as what? 5,000 Newton. 5,000 Newton. Now the next thing that we have to calculate here says if the stress in the wire is not to exceed 95 meganewton. So the stress is given as what? 95 meganewton per meter square. Now since the stress here, the load here is in Newton, we have to convert this guy to Newton. And this is the same thing as writing 95 times 10 to the power of what? 6 Newton per meter square. Because the word mega means 10 is power of what? 6. Now what you do is recall, right? Stress is given as the force over what? The area, right? But I'll call this the equation 1. But area is given as what? Pi d square over 4. Is that okay? Now if you look at this very well, the reason why we're using pi d square over 4 is because of what? We're giving diameter. So the bar we're talking about here is cylindric in shape. Now if I place it into my equation 1, I'm going to say that the stress, let me just input my data here. This will give me 3.142, which since I'm saying 22 over pi times what? D square, which we are looking for, all over what? Over 4. Now the area here will now be given 3.142 divided by 4 will be 0.7855 meter square. That is the area. That's a meter square. We call it d square, right? D square meter square. So the unit is a meter square, but we don't know the value of d. So anywhere I see a, I'm going to put 0.7855 d square. So I'll substitute this value into equation 1. So substitute a equals to what? 0.7855 d square into equation 1. Now equation 1 is telling me the stress is equals to the force, right, over what? The area. Now if I'm putting our value here, we are going to say that the stress is giving us 95 times 10 raised power what? 6. Now equals to the force P is given as what? 5,000 all over the area, which is given as what? 0.7855 d squared. Now if I take this to this side, right, I'm going to be having this to be 0.7, right, 0.7855 d squared is equals to 5,000 divided by 95 times 10 to the power of what? 6. So when I divide this, I'm going to be having 0.7855, right? D square is equals to 5,000 divided by 95 times 10 to the power what? 6. We'll be having 5.263 times 10 raised to the power of what? Minus 5. Now I'm looking for the diameter d, so I'll make d the subject of the formula. So dividing both sides by 0.7855, I'm going to be having d square will now give me 5.263 times 10 raised to the power minus 5 divided by 0.7855. Now in doing that, this will now be d square will give me 5.263 times 10 to the power minus 5 divided by 0.7855. That will give me 6.700 times 10 to the power minus 5. Now, if this square comes to the other side, it becomes square root. So say the d will now give us the square root of 6.700 times 10 to the power what? Minus 5. So in doing that, we are going to be having 8.185 or 8.186. So see the diameter d will give us 8.186 times 10 to the power what? Minus 3, right? So don't forget it is in what? Meter. Now we know very well that 10 to the power minus 3 is also called milli, right? So we see our d will now give us 8.186 times 8.186 millimeter, because this but 10 to the power minus 3 is equal to what? M, right? So this is what we have. So this is the diameter, the minimum diameter of the steel wire. It is cylindrical in shape. This is the minimum diameter that is required. So if you found this video helpful, please don't forget to click on your subscribe button. Thanks for watching.